Alright, this is M2-229 and 230. So it says, Saturday morning, Erica walked 30 minutes at a steady rate from her house to a park 3 miles away. When she arrived, she played basketball for an hour, then she caught a ride home with Kendall. She traveled at a constant speed from the park to Erica's house and arrived in 12 minutes. Number 1 says, define variables for the time since Erica left home in minutes and for her distance from home in miles. So, we, of course, are thinking variables x and y, and if you're ever confused about which should be which, time is almost always x, so the minutes will be x, and her distance will be y. 2 says sketch a graph for the morning, so this is going to be a pretty, rough graph for her distance from home over time. So, as she's walking to the park, she, of course, is getting further away from her home. And then when she's at the park, she's not changing her distance from home. And then she gets a ride back, but it's in a car instead of walking, so it should be a pretty steep ride back, something like that. 3, determine the rate at which Erica walked to the park and the rate at which she and Kendall drove home. Express the rates in miles per minute, so that's the unit rate. So, she walked to the park 3 miles in 30 minutes. So if we want that in how many miles does she do per minute for that unit rate, we'll have to divide 3 by 30. So let me pull out my calculator. 3 divided by 30. That's 0.1. So she's doing 0.1 miles per minute. That's to the park. Coming back from the park, let's see, she arrived in 12 minutes. So she did that same 3 miles, but now in 12 minutes. So we'll divide 3 by 12, and that's 0.25 miles per 1 minute. Number 4, determine the domain, which is time, and the range, which is distance from home. So that's our x and y for each part of the morning. So they're not very clear about what they want. I think we could be saying like whether it's increasing or decreasing. So domain, remember, is time, and then this is distance. So time is always increasing. We don't have much control over that. But as far as range, like that could be increasing, decreasing, or constant. So walking to the park, of course, her distance from home is increasing. While she's at the park, her distance from home is constant. It's not changing. And then coming home, it's decreasing because she's getting closer to home. Let's look at the back. All right, number 5, write an equation that can be used to model each statement. Erica's distance from home as she walked to the park. So this is why they wanted us to get what that rate was, because that's going to go for M, and our B will be 0 because she's starting at home. So I can look back. Walking to the park was 0.1. So Y equals 0.1. X, and I don't need to say plus 0. And then Erica's distance from home while she's playing basketball. Now, that was a constant, so there is no slope. She's not increasing. So there's actually technically a 0 for X, but she was 3 miles from home. So if we graph that out, that's just like a straight line. And then Erica's distance from home as she rode home from the park. So now remember, it's decreasing because she's going back home, and it was decreasing 0.25. So negative 0.25 x, and we're starting at 3, and then it'll go down. Describe what happens to Erica's distance from home in each part of her morning as time increases. So as time's going along, is she getting further away from home or closer to home or stuff like that? So walk to the park, further from home. playing basketball is the same distance. And then the ride home, she's closing that distance. She's getting closer to home. And then down here, you have those definitions of the increasing function, constant, or decreasing, which is kind of what we were talking about, where you're getting further from home, it's staying constant, and then it decreasing back down.